If you are visiting our channel for the first time, please subscribe first to get the latest updates.
Hello everyone. In our previous lectures, we have seen that how you can identify that the given relation, either in the form of ordered pairs or in the form of an algebraic function, how you can say that the relation is a function or not. But besides that, or besides using those rules on the ordered pairs, we can also have another technique to identify the relation as a function or not, is the vertical line test in case of the graphical representation of the given function. So graphs basically provides you with a visual technique to identify the relation as a function or not. So let's see how you can do this. You can do this by using a vertical line test. What is vertical line test? You can easily you can have a quick you can have the concept if we apply it on the graphs directly. Let's have few examples just for the sake of your understanding what is the vertical line test. Then we will also use the proper example. Currently you just have to know what is the vertical line test. So this is the coordinate plane where we have the graph of a function like this. This is the graph of a function f of x, and in order to find whether the relation or the set of ordered pairs represents a function or not, we can use what? A vertical line test. What is a vertical line test? Vertical line test is a test that a set of points in the plane or a set of points in the plane represents a function if and only if the vertical line intersects a graph at only one point. You have to draw a vertical line like, okay, this is what? This is a vertical line. Now, what is the purpose of this vertical line? This vertical line basically tells you whether the given function is a function, whether the given relation is a function or not. How? If it cuts the graph of the given function at one point, it means it is a function. And if it cuts it at more than one point, then it will not be a function. Now, what does it mean and what is the technique behind that? The technique is, here we can say, if I take this point is basically, you can say this is x1 and y1. If this line will be for example, if I further extend the function like this, if the function is like this, then the vertical line is again cut by the function at this point. Here again, what is the value of x? Here the value of x is x1, but the value of y changes to y2. Because why the value of x is same? Because this line is on the same point on the x-axis. This means we have the same x point, that is the same input value. At two inputs we are getting two different at two inputs we are getting the at two same inputs we are getting the outputs. So it, for a function, it is against the rules of the function that at two inputs we cannot get the one output. So that's why we use a vertical line test to check whether this function is cut by the given by the vertical line at one or more point. If it cuts at one or more points, then the given function is not a function. Let's have one more example. If I have a function like this where we have the graph like this, okay, so now I have to apply the vertical line test on it. Let's draw a vertical line. So I have drawn a vertical line like this. Now it is clear here that it is not a function. Why? Because it is cutting the vertical line is cutting the given graph at 2 points. This is point number 1 and this is point number 2, where the value of x is same. So we cannot say that this is a function, because it is violating the rules of a function that we have already discussed in our previous lectures, that the value of the input cannot be same at two places. So as we have already say that if f of 2 is equals to 3 and f of 2 is equals to 4, if this situation came across, then that means we have two outputs at the two same inputs. Then we can say that the given function is not a function. So this is what we call called a vertical line test to identify that whether the given relation is a function or not. Let's have an example. Let's plot a graph so that of a function so that you can have a clear concept. We have an example of a function that is f of x is equals to 2x plus 1. Now how we can plot the graph of this function? So step 1 is choose arbitrary values of x and find y corresponding to that. Let's find it out. For that, let's make a table of values like this, where we have input at one point and the outputs at the other. So it is not restricted that how many inputs you have to take and find the outputs. It's on you. So here we have x and here we have f of x. So if we take x equals to 0, then what we have f of x, it will be 1. How? Because we have put the value in this function. If we have 1, what will be f of x? F of x will be 3. If we have 2, it will be 5. If we have 3, it will be 7. If 4, it will be 9. If 5, it will be 11. And if 6, it will be 13. So these are the values of x and y so that we can easily plot its graph. Now let's plot these ordered pairs. Now these are the ordered pairs. How? As this is 0, 1, this is 1, 3, this is 2, 5, this is 3, 7, then we have 4, 9, then 5, 11 and 6, 13. These are the ordered pairs and we have to plot these ordered pairs. Let's plot them on the Cartesian plane. This is x-axis, this is y-axis. As we have all the positive values, so we need only the first quadrant for plotting. So first of all, we have the ordered pair 0 and 1. So first of all, we have 0 and 1. It means when x is 0 and y is 1. So it is at the point where when the point lies on the y-axis, on y-axis the x is 0. So we can plot this point here as like this. This is 0 and 1. Then we have 1 and 3. If x is 1, then y will be 3. This point will be here. This point. Then we have 2 and 5. This is 5 and this is 2. So this is the point. That is 2 and 5. Then we have 3 and 7. It will be 3 like this. And this is the point 3 and 7. Now we have to join them together. It will be like this. Now it's a little bit, the line is not straight as because this is not a graph. When you plot it on the graph, it will be pretty much better. So this is the line. Now this is how we can plot a function, and if I apply a vertical line test on it, I can easily find whether it is a function or not. So let's apply a vertical line test like this. This is a vertical line. This is for vertical line test. This is for vertical line test. So as this line is cutting the given graph at only one point, so we can say that f of x is a function, as there is no value of x that is repeating on which we are getting the y. So no two values of x are repeating, and the vertical line test is also successful. So we can say that this given relation is a function. Thank you.
Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.